Sorry, I forgot one other thing. Go to settings. Change that to that one, USB audio codec. That's this.
Okay.
And save. There we go. Now it'll use that, and this will pick you up a lot better than those. But again, remember to repeat the question.
Okay.
So.
Get started in just 1 minute. So I wanted to mention a few things about the big data group, the air quality competition, all that fun stuff that we seem to mention at every single meeting, no matter which one we go to. Next week, or so Friday, an air quality meeting on Friday at noon, just like we always do. Next week, we're going to have a meeting on Wednesday at noon at the Workers' Compensation building down in Sandy. That's going to be all from the air quality experts. So we're still working with Bryce, but we're going to have Matt Lemon to talk to us about what we should be looking at in air quality to give us much closer to the analysis perspective to really start kicking off the competition. The competition rules will be announced next week. Okay, so we're going to officially kick off and announce the rules, say what the competition is next week. Part of it will be at that meeting, part of it will be at that Wednesday evening meeting. There's a Wednesday evening. So, yes?
So the rules are announced on Wednesday or Friday?
So they'll actually be announced next week. They will be announced at the meeting, but most likely we will leak them on Tuesday or something like that as well. We have to get the website, that's when they'll officially go out. We will be up here standing talking about them on Wednesday and Wednesday evening. Okay? So we are getting them written up and finalized. We'll probably put them on the site and then we'll actually talk about them. So, but definitely Wednesday is the time to really be there for questions. Questions on getting started, questions on air quality, all those sort of questions. Wednesday afternoon is going to be the meeting you're not going to want to miss. We'll have experts there. We'll be there to answer the questions. So Wednesday afternoon is going to be an important one. 12 o'clock. As always, we'll broadcast and record it, but obviously you want to be there for the questions. So Wednesday afternoon, Wednesday evening, we have one as well. And then Friday, we have the Adobe lunch on Thursday, don't we? Yeah. Adobe lunch on Thursday, and then Friday, the normal will be open. So, as I mentioned, rules will be announced next week, and then a lot of those meetings will be covering a lot of those rules and stuff. And teams, getting those teams set up.
Yeah, we'll announce the rules and everything for each of those meetings so that we make sure people get out to them. Yeah. But we'll try to make sure it's not too redundant so that you're not getting bored by the time it's done. But start building your teams now. There's going to be a lot of things that come out to it, but you do want a larger team, just as a quick hint, for this particular competition.
Another 2 key dates coming up too, coming up in the future. September 13th, we are working on a hackathon during the competition. So keep that Saturday in mind.
It'll be more table style. It'll be about how accurate we can be. Much more of a technical solution, unlike the rest of the competition.
It's definitely not going to be something you want to miss though too. So September 13th, and then of course October 25th is Big Mountain Data. You can register at utahgeekevents.com or utahsqlsaturday.com. You need to get registered soon. We do not want to fill up and turn anybody away. We are looking for presenters as well, so if you're interested in presenting, Utah Geek. So Big Mountain Data, Utah Geek Events, or Utah SQL Saturday will be October 25th.
Do not register on the meetup.
No, don't.
You're there now. Switch over to
utahgeekevents.com.
You can't run everything from meetup. Rob, do you have a question?
Yeah, because I thought I had tried to sign up and I was waiting. Is that because I did it on the meetup?
That's on the meetup.
That's on the meetup, yeah. The meetup, registering at the meetup does nothing for our registration. Okay, you can put it on your calendar and that's fine, but you are registered if you go to utahgeekevents.com and say, I'm attending right there.
Right? It changes how we can contact you, it changes basically everything related to registration. So we said that. Also on the 15th, we will have a mixer in the evening at the Leonardo. That mixer is going to hopefully have venture capitalists, angel investors. We're also going to try to get executives out there to that meeting. Just a time for you to talk a little bit about what you did at hackathon, what you're trying to do for the competition, so that you can try to make some of this turn into business ideas or to help you out in your career. So it should be valuable, it should be awesome to do this. So,
I think that's all on tonight.
hopefully.
Yeah. If not, you'll see us from us in the newsletter or on one of the groups or something. So, other than that, we'll let you guys get started. If you have questions for us about air quality or anything, we'll be here all the time.
Thank you very much, Cloudera.
Thank you, Cloudera, for coming and sponsoring and helping us out. Let them go ahead.
Thanks, guys. My name is John Dara. I'm a sales engineer that's working in the Utah territory for Cloudera. And I just want to say it's very exciting to be here and to be in this community. Nick and Pat have done an amazing job with just building this and with such cool ideas like this air quality contest. I think that's pretty unique and incredibly ambitious. I just think it's really cool. I don't want to spend too much time up here talking sales pitch talk. I've been on the other side of these meetups and made the hair on the back of my neck stand up. So, but let me just say that you know, if you're working for a company that's exploring Hadoop and big data and wants some help with questions getting answered or developing use cases, myself and Dale Wetmore, who's an account executive with Cloudera, would be happy to help you with that. Happy to invest some time answering questions and helping you further your big data progress. So with that, I'm going to turn it over to Sean, who's going to give you information that you can.
Thanks, John. And I may be referring back to John, as he probably has more real-world experience on the practical side of things than I do. So don't leave, John, please. I don't think the mic up here is working, so can everyone hear me in the back? Am I projecting enough? Okay.
I don't think we're going to have a full room, so.
Yeah, and do speak up. This is intended to be a very interactive presentation, so please do interrupt if you have questions before I move on that you want to talk about. If you have comments or just something interesting you want to share, if you've done some of this before and just have some extra insight, please do share. I brought lots of Cloudera swag this evening. We may auction off the quizzes at the end, but I reserve the right to give out the most awesome swag for someone who has the most awesome comment. So just to whet your appetite a little bit, we have 20 Data is the New Bacon t-shirts to give out this evening. Always a crowd pleaser, very popular. Unfortunately, I do not have the vegetarian option. There is a Data is the New Tofu shirt. I do not have any of those this evening. We also have 3 books written by Clouderans. This is Hadoop, the Definitive Guide. And it really is. It is the definitive guide on Hadoop. It's especially good if you're brand new to the ecosystem. It'll take you just from the ground up, explaining the history of everything. And it really helps. You don't have to have any previous experience with Hadoop. It's really just the best way to get up and running. Also, Hadoop Operations, written by Eric Sammer. This is if you're a system administrator. If you're not the guy who cares about machine learning algorithms or the research, if you're just the guy who has to keep the cluster running, this is an extremely good book. Lots of practical advice. And Eric Sammer is someone I have a lot of respect for. He's got a lot of experience in that area, and that's excellent. And I have the Apache Scoop cookbook. Scoop is a tool for really efficiently transferring data between relational databases and your Hadoop cluster. And that's written by the people who built Scoop. So also a really reputable reference that I recommend. So there's those for this evening as well. So let's get started. And I'm going to have to be a little clumsy with the slides here because I've got one open to present to you and a second copy open for the Google Hangouts online. So a little bit about me. My name is Sean, as was mentioned, and I'm a software engineer at Cloudera. I work on what's called the integration team, which means that I know a little bit about everything we're going to talk about tonight, but nothing we talk about tonight is something I'm an expert in. So if you have questions, and they're easy ones, I can field those. Any question you have, I can probably find the answer, but I'm the guy who has the real broad view of the system and who integrates it all together, not the guy who's really done a deep dive into Apache Solr internals. I'm a committer on the Apache BigTop project. BigTop is basically the distribution project. The Hadoop ecosystem consists of all these independent projects like Hadoop and Hive and HBase. And BigTop is a project where we try and tie that all together and say, okay, no one's running just HDFS. They're actually running tools. And someone needs to be there to test all these tools together. So we take the latest upstream versions, we test them with each other. We work with the upstream communities to make sure that they're getting those integration issues addressed, because they're really just concerned about whatever version they happen to test on. And then we also do a lot of integration work with the operating system. So from BigTop, you can download Linux packages of the raw Apache releases, and it'll use Linux's system and configuration management properties. And so if you're a Linux user, BigTop's going to feel very natural to you as a way to deploy Hadoop. And BigTop was based on CDH, and CDH is now based on BigTop. So it's really just kind of the open source Apache version of Cloudera's distribution. I'm also a PPMC member on the Apache Sentry project, which is in incubation right now. That doesn't mean I know a lot about Sentry. That just means I did some stuff with Sentry when it was first entering incubation, which is the best way to get credentials on an open source project. And I'm a huge believer in free as in freedom software. So I've tried really hard tonight to have everything I show you be stuff that's open source. You don't have to pay Cloudera money for any of this. Obviously, John and I would appreciate it if you would. But this is stuff you can go home and you can do free of charge. It's all open source, except for one thing at the end. There is one thing that, as much as I try to keep it open source, Cloudera Manager is really awesome at doing some stuff, and I couldn't resist using it for setting up Kerberos. So at the end of some of the security stuff, I use Cloudera Manager just because it really saves me a lot of time. And I'm actually based in Colorado. I used to work down in Provo, and obviously JDogs was on my mind when I was setting this up. I was really looking forward to having JDogs on this trip, and I did not get any today. So I'm a little disappointed, but it's still great to be with you this evening. Okay. Oh, no, too far. Okay. The Enterprise Data Hub. How many have heard this term before? Okay. It's used mainly as a marketing term. I'm clearly not a marketing guy. So I want to explain this term up front because as a concept, I think this is absolutely brilliant. So I want to be really clear about what I mean by this, so that it's not just a buzzword. It's actually a really interesting concept about how Hadoop should be used. So Cloudera believes that Hadoop's ideal role is not just as an end unto itself. It's just the core of what we call a data hub. Now there's this term data lake that's been floating around, and the idea is just that HDFS is really good at storing any kind of data, and it can store a lot of it, and it's cheap. So just eventually send all your data there. Even if you don't have a use case in mind for it yet, just send it there and keep it there, and maybe sometime you'll use it. The idea of the data hub goes a little bit further. So it starts with flexible storage. So you can store structured data. So you can store tables of data, nested data structures, whatever you want. You can also store unstructured data, right? That's what Hadoop was built for, just massive amounts of text data. There should be data formats for flexible use cases. There should be data formats for columnar data, binary formats like images, formats that support deeply nested data structures, formats that support not having a strict schema when you're writing it. All that stuff should be doable, it should be highly performant, it should be scalable, and it should be very efficient. On top of that, you also need flexible compute systems. You need to be able to do batch processing, interactive SQL queries, interactive scripting, search, which is what we're going to talk about tonight, graph processing, stream processing, all sorts of other use cases that are coming to the Hadoop ecosystem. You should be able to do all these things in one cluster. You should be able to do them pretty well. So Cloudera believes that most of the stuff, the overwhelming majority of the stuff you need to do with your data, can be done with Cloudera. If you do want to move it to a legacy system or something more specialized, a data hub should have fast connectors to easily and efficiently move the data to a more specialized place if you need it, and then bring back the results. But the idea is you should have one system that does most of the stuff, can receive all your data, and can then move it to the more specialized places. It should also have, so that's the data hub. Where the enterprise data hub comes in, is it should have integrated security. It should have encryption all the way through built into the system. It should have tools for compliance and making sure you're complying with any regulatory requirements. And it should have integrated monitoring and management. So that's what I mean by the enterprise data hub. Now, what that means for this evening, for search, is that search is a whole lot more than just Apache Solr. Apache Solr is something that a lot of people have used to build search engines. But if you're going to bring this into the data hub, there's a lot more than just providing commercial support for that product. What that means is you need to integrate it with all the different tools in the ecosystem so you can search on the same data that you might be doing SQL queries on without having to move it to a completely separate cluster. So to get to the technical side of this, there's some specific integration points that I'm going to be talking about tonight. So Solr Cloud is a relatively recent development where they basically took the Apache Solr search server and they made it so you can distribute it. You can do it at a much larger scale on a cluster. And so we're going to talk about how it uses Apache ZooKeeper to do that. And I should mention, I'm not going to go into all the detail you would need to set this up yourself. I just want to give you enough context so that you can go and learn more about the parts that you care about the most. Solr is a project that actually has pretty good documentation, especially by open source project standards. Usually open source documentation does not exist. But I hope by this evening you know enough about ZooKeeper that you can get a ZooKeeper cluster up and running just using ZooKeeper's documentation. You're not going to need any hand-holding. You will understand the documentation after we speak tonight. So Solr originally just stores stuff on the file system like normal. But if you're storing really massive collections of documents, you need a distributed file system. So Solr Cloud will store stuff in HDFS. You can also store structured data in HBase, which we'll talk about. And there's a lot of different ways you can index these documents. So if you have a bunch of documents, to make them searchable, you build an index. So if you have all the documents already that you need to search, we'll talk about how you can do that with MapReduce. We'll also talk about how you can index data dynamically as it's coming into your cluster. So we're going to talk about how you can do this with Twitter data or log data as it's created using Flume, and also with HBase, which is used for structured data. As the data and the fields are changing, you can have that indexed almost instantly and available for searching in your cluster. We'll also talk about how you can manipulate data as it's coming into search with a new tool called Morphlines. And some of the security stuff, we're going to show collection level security tonight. In the most recent release of Cloudera, you can actually do document level security. So you can specify individual permissions for different documents and create really fine-grained exceptions. And we're also going to go over how Q can help you build a really attractive search interface that's really easy to use, really pleasant, and just all around awesome. Okay. So Apache Solr, as I mentioned, this is really the core functionality. There's a lot more to Cloudera Search as a search solution than just Solr, but this is really the kernel. It is a standalone search server, so that means you can stand it up and run it. You don't have to have Hadoop if you're just using Solr. And basically just runs in a J2EE container. It uses Jetty by default. In Cloudera, we run it on Tomcat, for those that care. Maybe no one does. And it basically uses and extends the Apache Lucene library. Now, the reason I bring that up is I actually found this really confusing. There's the Lucene project, and there's the Lucene library. So if you want to learn about Solr, you need to actually go to lucene.apache.org/Solr. So in terms of the way the project's governed, Solr is a subproject of Lucene. When you look at the code, the Lucene library is a dependency of Solr, and Solr exposes most of the functionality of that library. So Lucene, as the technical project, is just a library for doing really sophisticated text processing. So it's just something you can embed in your software if you want to do some text processing yourself. And then Solr just exposes that functionality to you as a search server. Very configurable and does a lot of different things. So there's full text search, so basically a glorified Control-F over your data just to search for keywords and things like that. It can do faceted search. And what that is if you're all familiar with Amazon, how you can search based on category, and then you can drill down by price ranges, and then some further nested categories inside that. So Solr allows you to do that. It does geospatial search, so if you've got some kind of location-based service and you want to find things near the user based on text they enter, and also does clustering and some pretty other sophisticated machine learning stuff. I know almost nothing about that. We're just going to be doing some full text search tonight. But I will show you a demo of how you can do faceted search in Hue, and it's you can see how user-friendly it can be. And then also very flexible in terms of the interfaces. So we're just going to be using some web-based tools tonight, but you can just use this as a backend inside your application and just expose it to the user in your own interface, just using JSON and XML, RESTful APIs, that kind of thing. So just some basic terminology. We're going to be talking about how you define the data you're going to be storing in Solr. And the two important things to know is data can either be stored in Solr, it can be indexed, or both. And if it's neither, Solr's just not going to care. Stored means that it's something that can be returned as part of your search results. So if you're searching for stuff on Google, the data that they show you on that page that matches your results, like the title and the little snippet from the top of the web page and some other metadata, that is stuff that would be considered stored in Solr. Stuff that is indexed is the stuff that you want to be able to search against. So that would basically be just Google's index with that their PageRank algorithm generates. It's not necessarily something that will be stored by Solr. So you can search against it, it will show you the results, but you won't be able to show that to the user and show this is what matched your query unless you also store that field. Does that make sense? I'm not getting any no's, so just raise your hand and ask if I need to go over it again, or if anything comes out confusing. So that was Apache Solr, and Solr Cloud is a more recent development as part of the Apache Solr project to make this distributed. So it adds sharding and replication and failover, and basically says, okay, you can run this on 5 different machines, and that that can double your capacity while at the same time doubling your reliability and just giving you kind of all the benefits of distributed computing. Very reliable, very scalable, and fault tolerant. So any questions on Apache Solr before we move on? Yeah. So basically, you have the structure is you have a collection, and inside a collection you have what's called documents, which you can think of as just records. So in the example tonight, we're going to have a collection representing each source of data, and all the documents will just be tweets. Now each tweet is then broken down into fields, which you could think of as being like columns. So we'll have the username and the text and maybe the data was created at. But it is very flexible, so that there's fields, but it isn't very strict. You can have fields that are present in one document that are absent in another. You can add new fields later. Yes, you can index multiple things. So when you have your schema, you'll have a list of all the fields that are part of your record, and you'll specify for each one whether it's stored or indexed or both. And you can have as many things as you want get indexed and stored. And I meant to repeat the question for people on the Hangout. The question was just if the documents that you store in Solr, if you can have multiple columns get indexed, have multiple fields stored and indexed, not just one key that you search on. Anything else to your question? Did I address it all? Great.
Not to go into hours of discussion, but what's some of the key differences between Solr and Elasticsearch? I know they're very similar, both based on the scene.
Mm-hmm.
Differences here between the two.
So this might be one where John would know better than I would. I don't keep up on all the competitive details. As I understand, they are very similar. Solr Cloud, generally when you have advanced functionality that is really important to businesses, someone's going to come up with their own solution, and then communities like Apache will generally kind of catch up, unless there's a company doing it, donating it directly to the Apache Foundation like Cloudera does. So I suspect they do serve a very similar purpose. Solr was kind of a thing by itself. Elasticsearch adds a whole bunch of functionality, like the ability to do failover and stuff, which Solr Cloud then added. But as you mentioned, they're both based on Lucene, and the goal of both is to expose all of Lucene, so you're going to find a lot of overlap. One key difference is with Elasticsearch, you don't get this, and with Apache Solr by itself, you don't get this either. The integration with all the other ways of analyzing the data in place. Anything I should add there?
I think you did it pretty well.
Okay. And again, I forgot to repeat the question. The question is, what's the difference between this and Elasticsearch? Conceptually, there's actually a lot of overlap between Elasticsearch and what I'm going to talk about tonight. They have tools. I'm going to talk about Flume. Logstash is just, their answer to the same thing.
Elasticsearch is the schemaless.
I don't know.
So, yeah, I think you're right. But I mean, schemaless is careful. I mean, Solr can do. In fact, I think the latest version of Solr can actually have schemaless search as well. I personally question the value of that. And you can do a lot with things like dynamic fields to essentially modify your schema or have a very adaptive schema. The true, completely schemaless, put it this way, anytime I'm on a data project and someone says, I don't have time or I don't know what the data's come in, I just want to throw it on the stack, it's like, well, okay. But I question what you're going to be able to get out of that once after you've thrown it out.
And not that I can really answer this any more authoritatively, I don't have experience with it, but when you say schemaless, the first thing that comes to mind is everything's in one field, and when you do a search, it can match, it can do a partial match inside that field. I would assume if they're advertising schemaless as a feature, there's something more sophisticated than that, but it sounds like if you dump it all in one field, you can do a match against that, but certainly you would want to break it out into more fields once it gets returned. But any other questions or comments on Solr? Okay. So let's move on to the next part here. So this does not seem like it would have a whole lot to do with search, But if you try and do this yourself and you stand this up on a cluster, ZooKeeper is something you're going to have to know about that Solr isn't going to explain to you if you read in Solr's documentation. So in a nutshell, ZooKeeper is just a cluster coordination service. Hopefully everyone who's a programmer here is familiar with the idea that you should never write your own cryptographic libraries, right? You've heard that you should use something else that's peer-reviewed, written by experts, well-tested, used in the field. ZooKeeper kind of fulfills the same idea for distributed systems. Distributed systems is something that's really easy to mess up because there's lots of naive assumptions, and it's not really intuitive how you should design it well. ZooKeeper addresses a lot of those concerns by giving you primitives that are well-tested and written by experts that you can use to add distributed functionality to your system. Going a step further, they also say you should never create your own crypto system out of established libraries. You should use a whole system that's been peer-reviewed, like Kerberos. If you want to use ZooKeeper in your own application, there's tools like Curator, from originally done by Netflix, now it's an Apache project, and it'll implement the common algorithms that people use ZooKeeper for. So if you just want to have a distributed fault-tolerant message queue, you just declare that class in Curator, and it will do all the complicated work on ZooKeeper for you. But if you're going to use ZooKeeper directly, and you'll have to run it at least if you're going to do Solr, you need what's called an ensemble of ZooKeeper servers. And that just means a cluster of ZooKeeper servers. But the nomenclature is the entire cluster is called the ensemble, and you always have to have at least a quorum, which means more than, not equal to, more than 50% of the cluster up at one time. So you always want to use an odd number of ZooKeeper servers, because if you have 5 servers in your ensemble, you can lose 2 and still be running. If you're running 6, you can lose, let me explain this the other way around. If you have 5 nodes, you can be running anytime you have 3 nodes running. 2 can fail and you still have service. If you have 6 nodes in your ensemble, you still have to have 3 to be running. No, you have to have 4 to be running, because if you're at 3, you're now at 50%, and the system can't, or 3 nodes being inaccessible and still running somewhere. And you might end up with a situation where each group of 3 thinks it's in control, and you end up with inconsistency. The downside is if you're running 6 servers, 3 failures is now more likely because you have 6 servers that can fail, not just 5. I think I got all the numbers right that time. But the idea is you always want odd numbers. So when you're starting out, to get fault tolerance and redundancy, you want to have at least 3. I don't know that I've seen any big clusters running more than 5 or 7 nodes. ZooKeeper is not really something that's always going to be getting a ton of traffic. So 3 nodes is sufficient for any proof of concept you're going to be doing. So what ZooKeeper is as a service when you connect to it, it looks just like a hierarchical file system, just like you're used to on Linux or Unix. It's just a hierarchy of files, and each file is called a Z node. Now, a Z node is different from a file in a Linux file system in that it can hold both data, so it can be used like a file, and it can also have children. So it can be both a file and a directory at the same time. So when you request the contents, you can request the contents, which is the data. You can also request the children, and they're 2 separate pieces of data about that node. Z nodes also can have special properties. They can be themselves, or they can be sequential, which means you'll create it in a certain directory with a certain prefix, and ZooKeeper will append a numerical suffix to that. So the first one you create will be your prefix 0. If someone else creates a Z node with the exact same name, it's just going to have that name with 1 on the end. And even if you do it from your perspective the exact same time, ZooKeeper will serialize those. One of you will get 0, one of you will get 1. So that's useful if you want to set up some kind of master election. Everyone registers a sequential node, but the guy who gets the lowest number, or 0, is the master. If 0 ever fails, 1 takes over. Does that make sense? See how that works? Nodes can also be ephemeral, which means when the machine that created that Z node disappears or doesn't talk to the ZooKeeper server within a certain period of time and times out, that node disappears. So that's how you can do failover between masters. You can use sequential nodes for the master election to say this server is in charge, and then when that server goes offline, his node disappears and the next guy can automatically be notified to take over. Z nodes can also have watches. So if you want to be notified when the master changes, and the server that you should be talking to is now a different server, you can set a watch on a Z node, and whenever its children or its contents changes, you get notified, and you can query for the latest updated version of that node. So basically the use cases here, you can use it as a reliable data store, because you can lose several servers and still get the data, and it's got strong guarantees about consistency. You can use it for things like master election, node registration. I've used it to build really high throughput message queues. And basically, this is used by Solr Cloud for all of its configuration. So when we do the demo later, we can go and look in ZooKeeper, and we'll see all the different pieces of configuration. And that's how Solr Cloud makes sure that it's consistent. You don't have to manually make sure that your configuration is everywhere. You change it in ZooKeeper, and it's everywhere. And that's also how it does failover. So if one node goes down, you can still look up what other nodes might have access to the same data. Any questions on ZooKeeper or comments? Yeah. Right.
So what happens if I'm using 5 nodes, one goes down there, then there will be an even number, right? And it's not going to make sense. What happens in that scenario if there are like 4 nodes?
Well, so technically you can run with an even number of nodes. It's just that if all you have is an even number of nodes, the probability of a failure goes up a little bit, and you don't actually get any extra redundancy. So if you have 5 nodes and one fails and you go down to 4, well, that's okay. You just need to get that 5th one back online at some point. But that's why you have monitoring and that kind of thing. So as long as you have 4 out of the 5, you're good. You can have 3 out of the 5, and you're good. That's fine. The point is just to get that back. When they say that you need a specific number of nodes, what that means is that you can't just scale up and scale down the ZooKeeper cluster at will. Because it has no way of knowing, okay, well, are those machines, have they failed? Is there a network partition? Can I not contact them? Or have they just been decommissioned on purpose? There is a Jira to add that functionality, but I don't see it coming anytime soon. Because as I said, this isn't the kind of service where your usage of it scales up and down dramatically. So if you need 5 nodes, you're probably not going to need 6 or 7 anytime soon. Make sense? Yeah?
So if you have 3 nodes, you have 2 nodes down. Can you just do the reads and writes both on the one node? Or
No, it'll just refuse any service. Because even though, yeah, it could read the data that it last knew about, it can no longer guarantee that it actually has a consistent view of the cluster, because the other nodes might be somewhere else still running and it just can't talk to them. So as soon as, basically from the perspective of ZooKeeper, one of the ZooKeeper nodes is elected as a master. The master is the one who makes all the decisions. So when you write, it's considered a completed write as soon as the master says it's completed. It will not say that until all the nodes agree. But basically the idea is that if you can't guarantee that everyone recognizes you as the master, you can't be the ZooKeeper server that serves up any data, because you can't guarantee consistency. Any other thoughts or questions? And I've forgotten to repeat both questions, so I'm sorry for everyone on the Hangout. Okay, Hadoop. So being a big data meetup, this may be something that more people are a little more familiar with. So HDFS is the Hadoop distributed file system. And in our view of this data hub, basically everything comes back to HDFS at some point. It's storing all the data. What HDFS does is it'll take a file, and it can be as large as you want. This is based on Google's file system. You can take a file as big as Google's index of the entire internet. What HDFS will do is it'll just break it into blocks. So maybe 256 megabyte blocks, and it's going to distribute replicas of that block to data nodes. So you'll take one block, and by default it's going to create 2 other copies and store them somewhere else in the cluster. It's pretty smart about how it does that. It'll try and store 1 extra copy close to the original, and then 1 copy far away. So if you need the replica, there's a copy really close by. You can get it with very little network traffic. And if the whole rack fails, you still have another copy that's as separated as possible, and you get the redundancy that way. So the replication is configurable. By default, it's 3, but you can tune that up and down as you need. The balance here is the more replicas you create, the more reliable it is, because you can lose more servers and not actually lose any data or access to any data. And that also can increase your performance. Everything we're going to talk about tonight tries and keeps the computation close to the data. So the more copies you have, the more likely it is that the cluster is going to be able to schedule the work to be done somewhere where there's a data, and it's not going to have to transfer that to another node to do the computation there. Does that make sense? So the more replicas you have, the more likely it is that you can do more parallel workloads. The downside is, if you're storing 10 copies of every block of data, the capacity of your cluster just got cut 90%. So that's why it's just a trade-off. You can configure it. By default, it's 3. So you have these data nodes that just store blocks. The name node maps the actual files to the block locations. So I might have a file called, my index of the entire internet, and it's going to say, okay, that's this block ID on this server, and this server. The next block is this ID, and it's on these servers. So what happens when a client wants to get access to a file, it talks to the name node and says, okay, I want this file, or I want the list of files in this directory, and the name node just gives you the locations. The client can then connect in parallel to all the data nodes, and it gets the data directly from them. Some tools, none of the ones we'll talk about tonight, but actually a lot of the ones we'll talk about tonight, you want them located with data nodes. So you may have one master server that's your name node. You'll have a whole bunch of data nodes. And when you're running Solr, you want to run Solr on the data nodes. So that when it gets to the data, it'll talk to the name node. It knows which of the servers Solr needs, on which of the servers Solr needs to access the data, and then it'll just get that data from the same machine. So most of the time, you're not transferring a lot of data before you can start processing it. It's just getting it from the machine that the server is actually running on. There's a lot of stuff I'm missing from the slide, obviously. It's a complex system. There's also a secondary name node that basically just offloads some of the tasks from the name node so that there's less chance of the name node failing. You can also run multiple name nodes for redundancy. Now, one key thing to understand about how this is going to work, even though it's a distributed file system, it doesn't do everything that you think a file system should be able to do. Since everything's split up into blocks, if you tweak something like inserting some data into the very first block into that file, that means you're going to have to rewrite that block. You're going to have to insert some stuff into the next block as overflow and rewrite that block. And you have to rewrite the entire file across the cluster. Not efficient. So if you ever have to do that, what you do is you actually delete the file and just rewrite the whole thing. What you can do efficiently in HDFS is you can append stuff. So a lot of the things we'll be talking about tonight, what they're doing under the surface is they're actually just logging updates to HDFS and making sure that when they read the data back into memory, they have all those updates. So we'll talk about HBase. HBase gives you like a tabular view and you can update stuff randomly. All it's doing is it's writing that to HDFS as a log, and once in a while it'll go back, compress all the updates together into one consistent view of the file system, and write it all back out to the file. And as I said, the reason this is relevant to search is you can use HDFS to store both your indexes and your collection. So your index can be bigger than a single machine can hold, and it'll be done reliably. Really no practical limit on the size of your indexes or the documents that you can store. Any questions or comments on the file system? Yes?
So earlier it was like second name node and secondary name node, right? But I heard like from Hadoop too, there's a checkpoint mode or something, which automatically takes over name node if the name node is failed. Can you explain a little bit about that?
Probably not. I think there's a journal node. I haven't kept up on the really recent requirements, but yeah, there's been efforts to kind of take some of the load off the name node. It used to be that the name node was a single point of failure, and if it crashed, nothing on the cluster was accessible until you got that back. So you had to keep it up all the time or backed up really well. So there's been a lot of attempts to kind of offload stuff. Now it's no longer a single point of failure because you can run multiple name nodes and they can replicate to each other and there's automatic failover. What you're saying sounds familiar, but I don't know enough to add any more to what you said.
Because I worked on it like 6 months back, so I'm not sure with the recent stuff.
Okay. Yeah, if you want, at the end I'll have my Twitter handle. Tweet at me any questions you want that I can answer, and I work with the guys who do, so I can I can go hassle them. Any other thoughts? Okay. So the other half of Hadoop, when people say Hadoop, sometimes they're referring to this whole ecosystem of tools that we're talking about tonight. Sometimes they're just referring to the official Apache Hadoop project, which consists of HDFS and MapReduce. MapReduce is basically the computation framework that was originally included in Hadoop. Very good at batch processing. There's a lot of attempts to try and make it more flexible to other use cases. But at the end of the day, Hadoop is really just designed for batch processing, especially with text, but you can't use it for other things. The way MapReduce works, and if you've done any functional programming, this is very similar to the way sometimes you'll do tasks in those languages, and these words will be very familiar to you. You basically break your computation up into several phases. And to do a particular task, you might have to have multiple MapReduce jobs that feed into each other. But in each job, the map phase, it'll take each record, do something with it, and it'll output 0 or more other records. So as an example, if I was building a MapReduce job to just do some basic statistics of some data, maybe generate the average, I might read in a line of log data into my map job. The map job would parse it, extract the data I need, and just emit the number that we need. So it's doing all the I/O and the parsing in one step. Now, because the map is just a pure function, it takes in the line of input and outputs something else without regard to any other lines of input. Very easy to do this in parallel. So basically, the mappers run on every single node where you have that data at the same time, perfectly in parallel. Yeah, so I'm saying, it tries to map each record on the data node it lives on. That's called data locality, trying to do the processing on the machine that has the data, so you don't have to transfer stuff over the network unless you really have to. So once everything has been mapped, you've gone from one set of records to a different set of records. The shuffle phase is now going to take this next set of records, sort it by key, and distribute it to processing. So basically, if I was doing this average example, my mappers would output a certain number that was encountered on a certain day. So maybe this is a log of thermometer readings. I'm going to output 15 degrees and the fact that that occurred once. What the shuffle phase is going to do is it's going to take all the records that say 15 degrees as a key, and it's going to put them all together and sort them. Now this just sets the cluster up for the reduce phase. The reduce phase is going to take each of those records in order and do something with them in order. So I can take all the 15-degree records and sum up the number of times they occurred. Then I can take all the 16-degree records and sum them up. And then at the end, what you're left with is basically a list of every reading and how many times it occurred. So it's pretty simple, but the idea is this is very easy for Hadoop to then split up and do in parallel so that you don't have to do that part of the work. But to do really sophisticated stuff, you have to do a whole bunch of MapReduce jobs. Yarn is actually a new part of the Hadoop project. Yarn tries to take all that cluster management aspect of it, and the idea of saying, okay, well, this machine's busy, so you run your part of the process on this node. That's now a separate project that's just like the scheduler. Yarn stands for yet another resource negotiator. So you have the file system, you have a scheduler, and then MapReduce is now just a computational framework you can run on top of Yarn. There's other frameworks you can run on top of Yarn as well. It's just kind of a generic scheduler for your cluster. Now, where this comes into play for Solr is if you have a large collection of documents already, so you just have massive amounts of books or other documents you want to index, you just run a MapReduce job that's going to go over each line, pick out the stuff that your Solr collection cares about and then index, and then output the records, structure the way Solr needs them, and feeds them right into Solr, all in parallel. So a very efficient way to do it if you already have all the data you need. Any questions on MapReduce or Yarn? All right. Okay, HBase. So some of the stuff we're doing tonight, we're going to do one set of documents in HDFS. We're going to index them in batch with MapReduce. Another thing we're going to do is we're going to take some structured data and update it in real time, which you can't really do with HDFS by itself. Anyone ever heard of Google Bigtable? Probably the same people who've heard of HBase before, actually, now that I think about it. Dumb question. Basically, what this is it's a very large database, similar to tables. If you're doing it with a relational database, you know the idea of tables. Basically, this will scale to billions of rows, millions of columns, and for each cell, you can do thousands of versions. And I'm not just pulling those numbers out of nowhere. This is intentionally the kind of scale that they go for, specifically billions of rows, millions of columns. So you end up with just a large table. You don't typically join stuff in HBase. There's no like SQL language to say, okay, take this table and do a cross-join with this other table on this key. You look it up by key, and your key can be split up into several fields. So you can have several fields in the key and look up partial matches starting from the beginning. So if I had a database of car parts in my inventory, I might have the first part of the key be a certain type of part, and the second part of the key be a specific instance of that part. Now, if I want to find all the parts of a certain type, I don't have to know all the keys. I can just specify that first part of the key, the type of part, and then scan for all the instances. So that's something HBase has over a lot of other NoSQL databases, the ability to do split keys and partial matches and that kind of thing. In the table, you have this key, and then you have a whole bunch of columns. The columns are grouped into column families. So normalization is done differently. Normally in a relational database, every table holds specifically one type of data. And if you have any slightly different type of data, you put that in a different table. In HBase, the idea is to take everything that can be represented by a certain key and keep it all in the same place. But you can separate it out by column families. So if I was a website and I had a table of all my users, I might have a column family that represents the login information, just what I need to authenticate with them and store their credentials. On another column, I might have their profile information, and on another column, I might have all the files that belong to that user. The reason you split up into column families is when you request the data, you specify the key or the partial key, but then you also specify the column families that you want returned. So if you only care about the login information, it'll ignore the profile information and all the other files. It'll just return and stream back to you the column family you care about. But inside that column family, you can have as many columns as you want. Break it down into as many fields as you like. Now, the really cool thing is this allows you to do the kind of data you probably need for a live website where users are updating data. It's not just the stuff that you append to a file. It's cells that might mutate over time. Now, NGData created a great tool for basically taking this data and indexing it into Solr. So as you create a cell, that cell will get indexed and can be searched by Solr. You can add a new cell. That cell will also be indexed. You can update the existing cell, and the indexer will go delete the existing record for that in the Solr index and update it with the new one. And then you can delete rows, and it'll just straight delete it from the index. So really great if you just need to be able to search up-to-date data. And a lot of these slides, they use the term near real-time. That just means, I don't know, it's not real-time in the sense that satellite engineers talk about real-time. I have not been able to catch it not keeping up yet. So it's basically real-time, just not instantaneous enough that we're really willing to call that, but it's really low latency. Any fields. Yeah, and you can specify as well. We'll go over how you specify a Solr schema for, say which fields you index and store. And the configuration file for the HBase side of this looks exactly the same. You just say, okay, this column in HBase maps to this field, and Solr will decide if it's going to index or store that. But you can have stuff in HBase that isn't indexed, and just pick out the fields that you do want to index and store in Solr. So yeah, pretty flexible. Any other questions on HBase or the indexer? I don't know that I have a separate slide for the indexer. Yeah.
Like basically, how you are making query like this. For example, I just want a record that came in only for today. How do we query on this page? How do we retrieve those records from this page?
So if the date was the main thing that you wanted to search on, you would make the date part of the key.
Oh, okay.
Right. There are projects, there have been some projects created to add multiple indexes to HBase. I'm pretty sure one's called H-index. But they haven't really been accepted by the upstream community in general, and they're not something that's usually part of Cloudera's platform. Generally, it's a little non-intuitive if you're coming from a relational database background, but almost all the time you can figure out a way to make your key exactly what you need so you can look up the data the way you need it anytime you want. You can also create secondary tables yourself, just mapping the date as the key to the key that you actually had to use as part of the data, and then just look up that table. So you're not really doing joins, but you can do key lookups very quickly. So instead of a join, a lot of times, you look up one key just to find another key, and then you look up the key you really want. Does that make sense? Sounded like gibberish in my head.
Like for example, something like based upon the region, like right now I want like based upon like Salt Lake City region and today. So how do we look at that like based upon the date and then the region, like doing those tools as indexes or?
Right. So basically, there's not multiple indexes. It's just one index. But you're going to have maybe the region, if that's the most common thing to look up on, with appended to that the date, and then any other key you want. And I don't think you can do matches in the middle of the key. You can just say, okay, any key that starts with this, and just scan for all of those. So you do want to make sure it's sorted so that the kind of the most important part of the key comes first, the thing you're looking up most often, and then you can have an hierarchy of less important keys after that. John, did you have a comment?
If you want to put it kind of like the relational database columns, think of a multi-column index. You can search on the first column, search on the second column. It's a 5-column index. You can't search right on the 5th column, but you can always search, continue to search, and add more columns and refine that search. Instead of multiple columns, you just have a key that has all these fields as part of that key, and then you can specify a each of the random keys. So it's very handy, very high, so you can scan a lot of those, and if you go all the way down, you're effectively doing a primary key lookup.
It's just first.
Yeah.
Any other questions before we move on from HBase? Okay. Oh, I do have a slide just for the indexer. Okay, so the way the indexer works is basically when you configure HBase, you're going to have to, and I've got to put this on a slide. Let me back up. The way HBase is structured is really similar to HDFS, and then you have a master node that kind of keeps track of everything, and then you have a whole bunch of nodes that actually store the data that's indexed by that master node. So you have a master, and then they're called region servers. And your HBase table will just be broken up into these regions according to row and possibly by column family. That's certainly possible. I don't know if that's implemented. So we'll talk about how it's configured later, but you also have to configure HBase to enable replication. And what HBase replication will do is you can have a separate HBase cluster, and every time your main one gets an update, it's just going to send that update and forward it onto as many replicated clusters as you want. So you can have kind of a hot standby or something that's updated. So this HBase indexer is just going to pose like an HBase cluster. It's not actually a separate cluster, but it's just going to be there so that it receives all the updates. When it receives that updates, that's when it has a look at what it needs to index, and it'll update Solr accordingly. Okay, I think I covered everything on there. Any questions on the indexer specifically? And despite not being an Apache project and being created by Ingedata, this is part of Cloudera's distribution. So if you get Cloudera Search, this is part of it. Okay, next thing, Apache Flume. So this is what I was talking about. This is analogous to Logstash in the Elasticsearch world. Flume is basically for ingesting streams of event or log data into Hadoop. A lot of people ask, when would you use Flume and when would you use Kafka? Kafka is much more flexible. You can configure it to do, I don't know, not a Kafka expert, but it is much more flexible in general purpose. Flume is for a very specific use case, but it is a lot better at that use case. So generally, if you're taking log data, there's the pun, it's the log Flume. It took me a long time to get that. Basically, if you're just ingesting stream data specifically into HDFS, Flume is going to be a lot more tailored to your use case, whereas with Kafka, going into Hadoop is just one of the many things it can do. So it's pretty flexible, but not as easy to get set up for that case. So the nomenclature in Flume is you have sources, and the sources might be Avro or Thrift, which are common data formats in Hadoop. They're also used for inter-process communication. It can be HTTP, so you can just download a website if it's just streaming data onto that website. Twitter, which is what we're going to do tonight, you can connect to Twitter's API directly and just download from the Firehose or the sample streams. With Netcat, pretty much all the, you think of all the different ways of streaming data in the Unix world, there's a source in Flume set up for that. So it's going to capture the data via these sources and then store it until it can be stored, store it temporarily until it can be stored in its final destination in various channels. You can have in-memory channels, which is going to store it in memory, obviously. Files were stored as a file on the, or it'll store stuff in a database. You just have it put it in a database temporarily, and then later on these syncs will go and retrieve that data from the channel and store it in its final destination. So the syncs include HDFS, which is what we're going to use tonight. You can do Avro files, you can post stuff to Thrift services. And the other part of what we're going to be doing tonight is Morphlines in Solr, which is basically where it'll take the data that's been in a Flume channel, prepare it for Solr, and then load it into a Solr collection as its final destination. So rather than just transferring the data from point A to point B, which by itself is not very useful, basically this allows you to have a lot of buffering, reliability built in, and do some processing on it. Morphlines lets you do lots of really cool manipulations for the data while it's in flight. And I don't know too much about them, but I know Flume also has the ability to do multiplexers, load balancers, and routing. So you can do fan out and send the stuff to multiple channels and have it end up in multiple locations. And Flume will make sure that that's all done in a very reliable way. So you're not getting 2 copies of the thing somehow replicated while it's being transferred, and you're not just losing records all the time. Any questions on Flume? All right. I think Morphlines is up next. Nope. Oh, okay, I'm going to come back to Sentry because that's kind of out of order. So Morphlines is something that was developed right before Cloudera Search was being introduced. The way I have heard it defined is it's kind of like Unix pipelines. So in Unix, you can chain lots of commands together. So they have really generic commands for doing different types of processing. And you can say, okay, here's the command for outputting a file. We're going to pipe that into a command that searches and only outputs lines that match a certain regular expression. And then we're going to pipe that into sed, and it's going to actually do some manipulation of the data. So Morphlines is the same idea. You can say, okay, read a line from this source of data. Now parse out these tokens. Now filter for records that have tokens matching these patterns. You can do conditionals, so you can send the data to one place if it matches a certain pattern, send the data to a different place if it matches a different pattern. Logging metrics, all sorts of stuff. The most important thing for tonight is that it has a command for storing stuff into Solr. So basically, Flume and Morphlines work together if you're ingesting live data, wanting to make it searchable immediately. You ingest it with Flume, you send it to the Morphlines sync, which will process it, break out the records that Solr needs, and actually put it into Solr for you before saying that that record has been processed. So this actually isn't even called Cloudera Morphlines anymore. It's now part of what's called the Kite SDK, which is just, it's not an Apache project, but it's Apache license. All sorts of tools to just make it really useful, make it really easy to build Hadoop applications. So a lot of common things like working with Avro files or Morphlines or various other things that Hadoop developers find themselves having to do over and over. This is just an SDK that helps you not have to reinvent the wheel quite so much. So Morphlines is just a part of that now. And the website, I think, is just kitesdk.org. But any questions on that one? Yeah. I could see some overlapping use cases. Pig is really, just a nicer way of expressing the batch jobs. Morphlines is for streaming data. I don't know if Pig has any kind of streaming functionality. Pig really just compiles down to MapReduce jobs. It's just going to do stuff in batch. This is really intended stuff where you've got something new coming in and going out. Maybe you're not storing it. Maybe you're just processing it. Really just stuff that's streaming in live. But I could see some overlapping use cases, sure. Any other thoughts? And let's go back to Sentry now. Okay, so Sentry is a fairly new project. Basically, it's trying to bring more security into the Hadoop ecosystem rather than just being something that we add on top. By itself, Sentry is just the authorization. It's not the authentication. So later we're going to do a demo with this. You do have to have Kerberos authentication set up to prove that you are who you say you are. Where Sentry takes over is saying, okay, now that I know who you are, I'm going to enforce what you can and cannot view. The idea is to eventually integrate this into pretty much everything in the Hadoop ecosystem. Right now we're focusing on Hive and Impala and Solr. Hive and Impala are just tools for doing relational queries on top of Hadoop data. Impala is, of course, way better. So with Hive and Impala, basically what you're saying, okay, these users have read or write access, or both, to these tables, table level authorization. In Solr, it was originally collection levels. You could say, okay, this batch of documents, this user can read them, but it can't update them. This batch of documents, off limits for this user. So what it does is it'll get a username. It's going to use Hadoop groups to map that user to a group. By default, Hadoop groups is just the same as the users and groups on a Unix system. So if I'm the Sean user and I'm part of the admins group on my Linux system, Sentry's just going to map that and say, okay, we're talking about a member of the admins group. From there, it's going to map each group to specific roles. So I guess admin's also a role. That's a bad example. Basically, users are part of groups, and groups have certain roles. From roles, you can define the specific permissions and say, okay, admins have access to everything, and they can update the data. Analysts have read-only access, and maybe it's only to a subset of the collections. That's a bad example of syntax. We'll go over an actual Sentry file later and show you how you define all this. But basically, this is additive. So groups, and I have multiple roles. Basically, all the access that any of those roles will give me, I have all at once. So it's not like some roles have certain permissions taken away. You have things given to you, and however many roles you have, however many hats you might wear at work, you have all that access at once. Does that make sense? So users map to groups, groups have roles, and the roles define your permissions. So originally this was just collection level security, like I said. And the most recent release of Cloudera, it's document level security. So you can make exceptions and say, okay, this user might not have access to this collection of documents, but there's a few documents in here they can access, and that's okay. They just won't be able to query everything else outside of that. One thing to know with Solr, you might have a collection called HBase tweets and Flume tweets, which is what we're going to do tonight. Admin is a special collection that basically gives you access to Solr administration. So if you want to create new collections, you have to have write permissions on the admin collection, even though there's actually no collection called admin. If you want to have a collection in Solr called admin, I don't know what happens. Just don't try it. Yeah, question in the back.
So you mentioned that HDFS level, it's just equivalent to like the group type access in
yeah, but by default. So the Hadoop group is just kind of an interface, and by default, the data node is just going to query, or the name node. Yeah, it's the name node. So however the groups are set up on the name node, that's what counts. By default, Hadoop's just going to query that. You can use LDAP as a backend. I don't know if there's anything else implemented, but since it's just a generic interface in Hadoop that Sentry will use, Sentry will just use that interface. Anything else you implement in Hadoop, Sentry will also use.
Is the idea that eventually they'll do apples and that sort of thing? Access control, that sort of
I'm not familiar enough with the nomenclature to say kind of what the difference in functionality is between having access control lists and, well, John looks like he's eager to answer your question.
Are you talking HDFS apples? Yes. Okay, so that is kind of a separate concept. That's more of a file system concept, and that we have that as well. This is more so. I won't talk too much about search because I know that kind of high level all use cases will be better. This is more, basically it's what the relation databases have had before you, where I have this role assigned to me. Therefore, I can see these 4 tables, but I can't see these. And going even a step further, I can see this view, which might actually limit me to seeing these 3 columns within this table, but have this column be masked. So it's more that role-based access control is what it's giving you. And it aligns really well to hide and all tables. And the Sentry, the search part, document level permissions are handled by having an actual field within the Solr index that says, here's the groups that are allowed to read this document.
Yeah, another question in the back.
So just clarification, default way you will return, you just want to return a search result you don't have rights to look at, or return a search result and then you try to access it as you can.
I can speak to how it works on the hide and call side, which is if you try to query a table that you don't have access to, it will just return an error message that says table of view does not exist. And it's I get some kind of like raised eyebrows when I say that, but it's actually from a security perspective, it's a good implementation because you tell someone this table exists, but you don't have permission to read it. As an intruder, I'm like, okay, I'm on something. I can start working this. So it gives you kind of, I don't know what you're talking about. I know nothing.
I think his question was, at least in my mind, and I have the same question, by default, is it wide open and then you go to set security levels, or is it very secure as a default and then you open it up?
So Solr is wide open. If you enable it, if you click the checkbox that says enable Sentry authorization, now everything's closed. Unless there's a specific user to group to role to permission mapping that says, yeah, you can do what you're trying to do. Any other questions or any other aspects of that question? All right. Okay, Morphlines we did. Okay, Hue. So Hue is basically the interface we're going to be using. If you're using Kerberos authentication, another case, we're just doing it on the command line like you would with the raw open source version of the project at Apache. Really tough to do with Kerberos, maybe just because I'm not that good with Kerberos. But Hue will manage all those for you, so you can log in as a user. Hue will then authenticate you to all these services and just make it really easy to upload files, view your jobs, write pig scripts, and build these. We're going to build some search dashboards in a little bit. Really great way to do that. So it's the Hadoop user experience. There's apps for pretty much everything in the stack. So there's an app for HBase, for HDFS, for ZooKeeper, for Hive, for Impala, and there's a search app. Yeah, any questions on Hue? Basically just a web app, just a really awesome one. Okay, so let's get to the demo of this. So I have to have points for bravery. I'm going to do a live demo on a VM. It might go really badly. Don't judge me. So here's basically what I want to do. I'm going to try to show off as much of this functionality as we can. So I have a local collection of tweets. They're not really tweets. I just tweeted a numerical sequence. So the tweets are like 0000001. That's because I don't have permission to distribute Twitter's data. We're going to index that with an app reduce job and just put it into Solr. So it's just a batch of documents, put it in Solr. Then we're going to take actual tweets from Twitter's sample data stream. We're going to index them, and we're going to create a really nice looking dashboard where you can search for these tweets, search for, usually I like to make fun of celebrities. So once I did Kanye West and saw the weird things that Kanye West fans were saying, sorry if you're a Kanye West fan. And then we're going to create an HBase table, also with tweets. Every row in the HBase table will be a tweet. And we're going to make some updates, and you'll see how that updates in real time as well. Then, and this is the part that I won't demo this unless there's a lot of interest. And if you really need to come up and talk to me afterwards. As I said, Sentry requires Kerberos, and Kerberos and Cloudera Manager and all the stuff that's designed to be distributed does not like it when you have all of it on one VM and you reboot that VM. Not a good idea, because it's assumed that, if you can have a failure, one thing might fail, but having the whole thing go off at once and then come back online, it's got a lot of checking to do to make sure that there's consistency, and it doesn't know not to do that in a VM. So the security stuff at Kerberos, really ambitious if I try that, but I might try that. So I'll just kind of demonstrate how permissions work, and we'll at least walk through a configuration file so you can see how you specify the permissions. And as I said, we're going to create some really nice looking search dashboards in Vue, and we'll also show you an example of faceted search and just how powerful this can be. Okay, if you'd like to follow along, I posted this on the meetup last night. I'm going to use the Cloudera QuickStart VM. It's basically everything that's in the Cloudera platform installed on one VM. So really useful for just testing stuff, learning about the platform. I don't recommend it for performance. Like I said, this is designed to be distributed and not all smashed onto a single VM. So I mentioned the front. I'm a huge believer in open source software, and I would tell you when stuff is not open source. Cloudera Manager, everything we're going to do tonight, and the versions in the VM is free of charge. You can use it. You can use it in production if you want. We're not going to use any features that you actually have to pay money for, but it is the only thing here that's not Apache licensed. So just be aware of that. And there's a project. You really can't see that. GitHub.com/McCrorySD/BigDataUtah. Let me see if I can make that any clearer. It's a PDF. I'll post it online afterwards, don't worry. Oh, also recorded. Okay, I do have to have this disclaimer in here. As I said, I'm going to be streaming live data from Twitter, and at one point in the dashboard, I'm going to be showing users' avatars on the screen. I promise I will do a very benign query. I'll search for music or something. One time out of 20, you're going to see something you don't like. That's what happens when you use raw Twitter data. So I will tell you when this is coming, but if you do not wish to be subjected to offensive graphic images of people's privates, there's a chance you might see it if you don't close your eyes. But I'll warn you when that's coming up. Everyone agree I'm not responsible for what you see during that portion of the demo? All right, good. So I'm going to have to switch things up a little bit here so I can see what's going on the screen and take you into the VM. There we go. Talk amongst yourselves. Yeah, will do. So this is... No. Yeah, I'll post the slides and also the example project. The example project has a README, so anything we don't get through tonight, all the commands and all the source files are there. So like I said, I hope tonight you have enough context to understand it. You should definitely be able to walk through that and do all this yourself. And if you can't, tweet me and I'll fix it so it's easier to understand.
All of this will be recorded on the YouTube channel. Like we found on the big data you found out on the side.
Already going out.
Okay, so what I'm going to have to do is I'm going to have to come on this side so I can see what's going on the screen, because it doesn't look like I can clone my screen and share on the Hangout at the same time. This is going to be really tricky from this angle. Okay, so yes. Like I said, you got to give me credit for bravery here. Doing a live demo is not fun. Okay, the Hangouts, Google Chrome. Yeah, KDE seems to have changed their interface since I last updated. So can't duplicate. So I'm going to have to look up on that screen to see what I'm doing. Okay, screen share, and we're going to share the VM share. Okay. I can kind of see what I'm doing on the Google Hangout, actually. Except the mouse point is off by a little bit. Okay, is that easier to see the URL? So if you want to follow along, that's the project I'm using. And as I said, there's a nice README in there. So the first thing we're going to be doing is we're going to take just a file I have on this VM, and we're going to index it using MapReduce. So the first thing we need to do is create a collection in Solr. And let me expand this a little bit for you so you can see. Is that good? Everyone read that? Okay. So I'm just going to use the collection name here. We're going to do this a bunch of times. We're going to create 3 different collections tonight. But the process to create the collection in Solr is identical every time. So the folder just gets created each time. So this first command here, Solr control instance directory create. This is just going to create just a skeleton configuration for Solr that we can start off with and modify for our needs. So we're just going to place it in the home directory as the collection name _configs. The next thing we're going to do is we're going to take, so this schema.xml, this is part of the project that you can download. And I'll open up this file in a second so you can see what a Solr schema looks like. We're just going to copy that schema into our configuration so Solr knows this is what the records will be structured like. Then we're going to, yeah, I'm on the right line. So this next command, as I mentioned, Solr Cloud uses ZooKeeper to store its configuration to make sure all the nodes have a consistent view of the configuration. This next command is just going to take this configuration we created, going to upload it to ZooKeeper and create the directory structure in ZooKeeper that Solr is expecting. And the final step is to tell Solr that now you're going to start looking at ZooKeeper to keep track of this collection. The -s, I believe, is the number of shards. So that's just a measure of the replication. If you want to keep 3 copies of all these indexes on your cluster, you do -s3. This is just one node, so there's one of everything. Okay, any questions about that process? So in the project, there's a script that will just do all those commands for you. So I'm just going to go ahead and do that right now, so we don't have to worry about it again. Create collection. The first one will be MapReduce tweets. So it creates a skeleton directory. It's uploading them to ZooKeeper right now. And the last step will be to tell Solr to start serving up that collection. Any questions on this process? All right.
Because you're on one node and you're using Yarn, without using Yarn, and you know about it.
I actually am using Yarn. There's just no reason for me to do so other than the fact that I'm showing you how to do MapReduce. But yeah, so I forgot to mention this. Now when you create a MapReduce job, you don't have to have MapReduce daemons running. You just have Yarn running as a generic scheduler. When you create a job, it just submits a specific application to the Yarn cluster to run that just represents your application alone. So that's a big difference between Hadoop 1 and Hadoop 2. Okay, so Flume tweets. This is going to be the live data we ingest from Twitter, and that might offend our eyes. There we go. And the last thing, HBase tweets. Okay, so while that's working, let's go on to the next section. So we'll come back to Hugh in just a second. Okay, so indexing and MapReduce. Again, we're going to have this collection name very well defined. And this collection name can really be anything you want that just represents a certain collection of documents. How's the color on the terminal? Is that easy for everyone to read? Okay. Okay, so the first thing we need to do, these are just the HDFS commands. They're going to look pretty similar to you if you're familiar with Unix. Just make directory, and this is the directory we're going to store all our tweets in HDFS. I have them on my local file system. I'm going to load them into the distributed file system that in this example is not actually distributed. Simple, right? Okay, oh, and then I'll just do these all at once. And then copy from local basically takes the file on my local file system. It's just an Avro file. We'll actually have a look inside an Avro file in a second. It's basically just like a binary JSON format, and then it keeps the schema with the data all the time. So even if you change the schema, old records are still readable. You can add fields. This is not working very well for copy and paste. What's that? Well, it's also because I'm looking at the Google Hangout, so like my cursor's off. Let me. Anyone see my cursor? No. Oh, there we go. Okay. So my cursor wasn't even on the right window. Okay, so these commands. Perfect. We'll just paste those into our terminal. So create the directory and copy the file. Okay, so there's a tool called EvroTools. This will let you read files that are written in Evro. Like I said, it's kind of a binary format. It's made to be efficiently read, not really easy to read. But there's a command you can use, EvroTools to JSON, and then we're just going to look at that same file just to show you what this looks like. That's a little weird. Oh, yeah, because there's actually two files. Okay, so there's a JSON representation. As you can see, it's really just an array of objects, but every object has like a friends count and text. So that's just kind of the raw data that we're indexing. And as you can see, it's just, well, you probably can't see because it's buried in there, but the text of each tweet is just a numerical sequence at this point. So the final thing we're doing, once our documents are loaded into HDFS, we launch this job to go ahead and index them. So it's just saying, okay, we're going to launch a Hadoop job using our default configuration for Hadoop, and we're going to, each job is defined by a jar file. It defines the classes for your mapper and your reducer. So we're going to use the search map reduce job, specific class, just some generic Java options that happen to work pretty well. I've forgotten all the reasons these got added. So the Morphlines file is just explaining how this Evro record needs to be translated into a different format before it'll get loaded into Solr. Output directory, this is where Solr is going to store it. Pointing to a specific instance of ZooKeeper for the configuration, and the collection name, and the directory at the bottom that we're going to load tweets from. So let's just run that job. And should just take a second. So that'll run for a minute. As I said, Hadoop's made for batch tasks. So for little things like this, it's kind of disappointing in performance because you expect Hadoop to be really fast. The point is that all this overhead is not that much bigger when you have to do billions and billions of records. So for little things, MapReduce isn't really the best option. But the point is this is massively scalable and extremely parallel when you do have to do it on a lot of data. So any questions to this point? This is kind of the end of the MapReduce example of how we're going to load the data in. In a second, we'll go into Hue, and we'll show you that you can actually index, you can search this and create a nice little dashboard for it.
So here you just use a basic mapper and reducer, or did you use any combiner or anything like that?
So in this one, that jar file that I referenced, so that defines the mapper and reducer, and that's part of the search project. So Cloudera Search is both like a product you can buy from us as like a comprehensive support package. If you also go to github.com/Cloudera/search, there's basically all these bits that we feel is important for a well-rounded search solution, but that really don't fit into any specific other project. Like there's no project that's just a collection of MapReduce jobs for you to use, but this one's really useful for search. So we wrote that job, you use that jar, and you just provide the options like saying, okay, you're going to read from this directory, output to this directory, and here's the schema. Make sense? Okay, it's done. So let's go have a look in Hue. Hue, as I mentioned, is the web-based interface. And everything on the QuickStart VM, the credentials are pretty much all Cloudera. But not only do I not recommend this for performance, I don't recommend it for security. Don't make this publicly accessible inside your network. Okay. So real fast, if you open up Hue for the first time, you're going to see these examples. And these are just example data sets if you want to get a feel for one of these components, but you don't want to go to the trouble of learning everything about it just yet. So we'll go ahead and install the Solr example. Installing. And these examples, for search at least, the examples read only. So you're not going to be able to like manipulate the data or customize the query. It's just really a demo of what Hue is capable of presenting to the user. As I mentioned, faceted search is a really powerful one. And that's what I'm mainly installing this for. Let's go over to the search app while that runs. Oh, it ran. Okay, so these are some of the examples we can have a look at. Apache logs is especially impressive. So this is basically, I think it's just the commit logs from Git of all sorts of Apache projects. No. See, live demos. Very scary. It may just still be loading. So we're actually going to do. So up here, these are all the collections that have been loaded in because of the demo. We're going to create a new, well, not create a new collection. We're going to tell Hue about this new collection that we want to display. So we called our collection MapReduce tweets. Note here that I've got the actual collection that I care about, but then there's also going to be MapReduce tweets shard1, replica 1. So for every shard you break this up into, you're going to see an entry in here. And for every replica that it keeps, you'll also find it in here. I'm not entirely sure why they did that, unless you do know which shard your data is in. You just want to use that in Hue. But for now, we're just going to use the entire collection. And we'll use everything. Oh, that was just a list of indexes. So we're going to create a new dashboard. We are going to select. Oh, no, that's create a new dashboard. Okay, so this is a new dashboard. We're going to edit this. We're going to pick the MapReduce tweets collection. There we go. And at the top here, you can choose from a couple different layouts. I'm just going to go with a single pane one. You can also do one, and you'll see this in the Apache logs demo. There's one pane down the side, and that's a good place to put faceted search, like the drill down options. And in the center is where you're going to put your main results. But for now, I just want to show you that this is indexed. Various elements you can put in here. We're just going to do some raw HTML. So right here, there's an editor that represents each row, and this will be replicated for each record. At the top, there's also a header, so you can provide just some introductory information. Now, by default, this HTML element, it's going to include every single field in our tweet, which is the text and all sorts of stuff about the date, the user. So each of these little fields you see, that's just one of the tweets we indexed. We're going to come back later, and we're going to make this a little more user-friendly and narrow this down. But for now, I just want to show you that you can put any HTML you like in here. This is actually a WYSIWYG editor. You can edit the raw HTML just by going to these tabs. But then just to show you at the bottom, these are the actual tweets that are indexed. So right now it doesn't look nice because we haven't customized the styling, and we're just showing all the data that we have. But you can see here there's some URLs to where the data is indexed, what file this came from, and you should see at the end, yeah, the whole numerical sequence. So those are just the tweets. We're going to see some nice tweets in a second, but that should give you a feel for how we index stuff in MapReduce, and you can show it in Hue. So that's the end of. Let's check out Flume now. So again, we have this collection named Flume Tweets. We already created it at the beginning. The first thing we're going to do is we're going to take this tweets collection configuration. We've already given it to Solr, but we also need to give it to Flume because Flume's going to be working with it as well. So we're just going to copy that configuration directly. Not going to modify it at all. Oh, that was bad. And it's an underscore. Okay, now we can paste. So now's a good time to have a look at this collection. I just want to show you the schema so you can see what a Solr schema looks like. So we're going to look in Flume Tweets, conf, and then just schema.xml. Everything else is just kind of boilerplate defaults and some examples. So lots of comments. We'll ignore the comments. You just define a schema. There's an opening tag for the schema here. Can everyone see? Is that font big enough? Going down a little bit more, lots of comments. Here's the important part. So we're going to start off defining a list of fields. And each field, as I mentioned earlier, is kind of analogous to a lot of comments. To a column in a database. So here we have the field named ID, the type string. And I mentioned you can index things or store them or both. So the ID is both indexed, so you can search for a specific ID, and stored, so you can retrieve that ID back later. And certain things are required. In my experience, it's not actually required. If you try and submit a tweet with that field missing, it does seem to index it. I don't know if I'm missing something. You know much about that?
So the ID field is, the way it was explained to me by one of our guys is it's not required, but weird things can happen if you don't have the column ID or the field ID and the field version. Okay. Those are two fields you should have in every search.
Okay. So like C's notion of undefined. It's just no one said what should happen, so you're on your own.
Yeah, I like it.
Okay. So just the same thing for every field. We're just going to define its name, its type, whether or not we index it or store it or both, and that's about it. There's a bunch of other stuff at the bottom here you're welcome to look at if you want to dig deeper into this example, but I just want to cover the basics and show you basically how you define the fields and what you do with them. Okay, so we copied our configuration. And before I move on, this is one thing I forgot. Just want to show you quickly in ZooKeeper. There's a client you can use to connect to ZooKeeper and look around the file system. As I said, it's just like a Linux file system. You can look around. You can see, you can do ls, root directory, and you'll see there's Z nodes for Solr, for HBase, and for ZooKeeper. Most of the components in the platform are going to use ZooKeeper for failover and things like that. So you'll see directories in here for each component. So let's have a look what's under Solr. You can see this configs, cluster state. It's going to have a list of all the Solr servers, all the collections, all the schemas for those collections, all sorts of stuff. In practice, you shouldn't have to look at this very often unless you found a really serious bug. But I just want to let you know it's here in case you want to use ZooKeeper to build your own applications. This is how Solr uses it. Just a directory for all of its own stuff that it uses as a root, and then list of nodes, list of collections, all that good stuff. Okay, so back to the Flume example. We've copied the record. This next thing, we're basically going to take the so twitterflume.conf there's a Flume configuration file that defines Twitter as the source. We're going to tell it, okay, how to connect to Twitter, what authentication credentials to use. Tutorial read avro-container.configuration. That's a Morphlines configuration file saying what steps to go through, what phases, and some of the parameters for it. And that's basically just saying, okay, we're gonna be transferring this data around as Avro objects. That just tells Morphlines how to work with that object. And since we're starting off with a template, the template uses collection1 as the name. So we're just going to use this sed command here and replace it with our actual collection name, which is Flume tweets, which I have now remembered to define. Okay, let's have a quick look at that configuration file for Flume. Okay, so at the top, we just define our source. We call it Twitter source. We're going to define Twitter source below. The channel is just a memory channel, and the sink is where the data ends up in Solr. So a bunch of stuff to configure for the source. So there's the class to use, and then we're going to have to put in some credentials here. So what I'm going to do is I'm actually going to take this VM off the screen while I put in my super secret credentials here. Actually, I'll do that in a second. Just more parameters for the source, and eventually we're going to define the sink. So down here at the bottom, we specify the class for the Morphlines and the configuration that it needs to be using. Just etc flumeng conf morphline.configuration. So pretty straightforward, just key value pairs to define your source and the parameters, your channels, and the sinks. Does that make sense? There's tons of stuff it can do. It's really configurable, so I don't want to spend too long on that. But what I'm going to do, I'm going to bring the VM over to this machine and just give it my credentials. So to get these credentials, by the way, you just need a developer account on at twitter.com. Just go to dev.twitter.com and sign up. And you go through the mobile app that used Twitter. And then for that app, it will give you 4 different keys. There's an API key, and API secret, and a consumer key and a consumer secret, something like that. And you just copy them straight into this configuration file, and it'll connect for you. While I'm doing this, any questions so far that we should talk about while I'm copying and pasting? Awkward silence it is. The way I kind of picture it is that Flume kind of buffers a bunch of stuff while it's in flight. So I picture kind of like a sink. You can fill up a kitchen sink with water faster than it can empty, and then once you just stop flowing the water, the sink will just kind of buffer it while it drains out the sink. So I guess it's analogous to just the hole at the bottom of the sink that's going to drain it to where it's finally going. Almost there. Okay, now we move back over here. Okay, so really all I did is, there's placeholders in that file. You'll see it. It just says in big letters, your Twitter key here. And you just copy and paste it in there. The next thing we need to do, Flume, Twitter authentication also requires the time on your machine to be in sync. So we're going to go ahead and sync it up now. In practice, this wouldn't be a issue. There we go. Oh, one other thing. Just taking the default Flume configuration, and you see there I'm setting -d/solrhost, just telling it which Solr server it should be using as the sync loads this data in. Okay, we did that. Now we'll just synchronize the time. And now we start the Flume agent. So the agent, Flume can run on a bunch of different servers. The agent is just the daemon that runs on each individual server. So we're going to start that. And now we tail the log. And we'll see if it's successful, if we have any problems. And it'll read out to us as it's indexing these documents. So just some startup. Looks okay. So process 300 docs, 400 docs. So that's each document is a tweet. So we've now indexed close to 1,000 tweets, and they'll be available. So what we're going to do is we're going to go to Hue, and we're going to create a new. Oh, I should save this one before we continue. Click save. New dashboard. Okay, we'll call this Flume tweets. Go with a single pane as before, and we'll go with the HTML element. Okay, this is the portion where you may see offensive stuff. For now, it's just going to be text. But I just want to show how attractive Hue can make this. So there's some templates here in the README. If you head up to the top, so there's some HTML. This is just going to define, which fields are we going to show here. We're not going to show everything. We're just going to show, the actual text of the tweet and the user's name. We're going to retrieve their avatar. So right now we're in like a WYSIWYG editor. We're going to click on the HTML editor here. And rather than just a div that contains everything, we're going to have this nice little structure that shows only what we want and in a more pleasant structure. The other part here is some CSS, just to make it a little more attractive. Let me go from the top. So we'll hop over here to the CSS and JavaScript tab and add our own CSS. Okay? So we'll save this, and then I will try as quickly as I can to put in a nice innocent query so we just get some cool tweets from people. Page saved. We'll reload that.
Something about air quality?
Air quality. We'll look up air quality. That's perfect. Okay, so we're already seeing tweets. You can see there's people's usernames, and I really hope that that isn't something offensive in Arabic and that no one here speaks Arabic. But so, air quality. We'll type in here. Air quality. Nothing. So one thing, not super surprising. So the free access you get to Twitter's API just gives you a very tiny sample. As you saw, it was just a couple hundred tweets every few seconds. If you are really important and you have tons of money and Twitter agrees with you that you need access, you can get Firehose access, which is everything. There's also a different endpoint you can use in Flume where you can specify a specific query and it'll return everything up to a certain rate. So if you only care about air quality stuff, you can have it save you the trouble of filtering out and only get air quality stuff, and then you can do search analytics on just the air quality stuff. So
it's 100 grand for the Firehose?
I don't know whether they have a public price. They just say you probably don't need Firehose access, but if you do, you should call us. And there's no number there, so you have to be important enough to know the number anyway.
Nice.
Usually, as I said, I make fun of celebrities. I think this week a Robin Williams tribute is in order. Let's see some of the nice things people are saying about him. Live in peace. Watch all Robin Williams movies for free. That sounds legal. So there you go. Nice search tool. And while we're in Hue looking at how pretty it is, let's go back to this Apache logs thing. Let's see if that ever finished loading. Yay! This is really taxing my machine right now. So apologies for the small window, but this is just VGA. You can see here, these are the Apache logs and commits. It might be view logs. Do you know, John? Okay. So basically, this is just some log data. In the field for each record, it's going to have some code that lets us do geotagging on this. So you can drill down by stuff that's in the United States, China, India. You can do graphs based on what time of day the event happened. You can do maps where you can drill down. The countries in dark blue are the ones for which we have records. So you can go over the United States. We have, what is that, 1923 records? China, India, all sorts of cool stuff. So rather than just this nice, pretty Twitter interface, you can really do some sophisticated interfaces, drill down, show a lot of detail, and make this a pretty powerful tool. As I said, this is read-only, so what you see in the dashboard is what you can drill down by. But just as an example, what you can do with Hue if you can spend more time than we have tonight.
What are the records that you showed me when you see 1923 of those?
Oh, look here. So this is not from Twitter. This is just one of the examples in Hadoop. I think this might actually be web logs from. Oh, you know what this is? This is the Apache weblog from Hue itself. So these are the requests that came in, and these are all the places that those requests came from. Okay. So any questions on the Flume example or on Hue? All right. So the last thing we're going to demo tonight, and then we'll finish up, HBase. So again, I need to define collection name.
Sorry.
No worries. What's up?
So Hue, it can like generate a page and like save it off and view it outside of Hue, like.
Well, I'm sure you could save it just in your browser. But the idea with Hue is you set up the dashboard to do certain queries. Whenever you view that dashboard, it's going to show you the results of those queries right now. So each time you view it, it's going to actually make those queries and then display the results to you the way you've configured.
So I mean, let's suppose you have Solr, then you want to have a production website of it, but you want to build that with Hue. Like you could build that dashboard with Hue, and then display that dashboard outside of Hue.
I don't think you can do that. No, Hue's really a tool for users in the cluster. So you log in, and the user you log in as defines your permissions. So you wouldn't use Hue for that exactly, but as I mentioned, Solr has lots of interfaces, so you would configure Solr the way you want, and then you can use these RESTful APIs directly in your web application to query it. But then you wouldn't be able to use Hue's charting abilities and that kind of thing. You'd have to chart the data yourself. But you can query the data pretty much any way you want.
But if you had somebody that wasn't a technical user, can you still give them an admin right to go in and do what somebody else is doing?
Yeah, Hue is pretty much made for non-technical users. So when you create these dashboards, I, as the admin, can create them. And if other users have permission to query them, you can log into Hue as your user, and you can query that same dashboard. You can bring it up. You don't have to edit anything. You may not even have permission to edit anything, but you can see the results of those queries as long as you have permission. I'm going to go ahead and stop Flume here, because I don't want to process 30,000 tweets on this already overloaded VM. All right. Okay, so we defined, did we define? We did not. Define collection name. So the first thing we're going to do is we're going to enable replication in HBase. I think we're running a little behind where I wanted to be, so I won't go into details, but this is just an example HBase configuration. By default, HBase runs in, what's it called? Standalone mode, where everything's in a single process. There's no master and region servers. It's just a single process that gives you the HBase interface. You can put it in distributed mode, which on the single VM lets you have a separate process for the master and a separate process for the region server, or multiple region servers. So this configuration just puts it in distributed mode and enables replication. And if you want to see how that's done, the files are included in the project. And then we're going to start the master and oh, this curse is really becoming a pain. Just restart the services now that we've enabled replication. Okay. So in the HBase shell, this is a nice little Ruby shell for doing stuff on the command line. There's also a Hue app we'll use in just a second that can do all this stuff for you in a slightly more user-friendly manner. Okay, HBase shell. We're just going to create a table called tweets. And right now we're just defining the column families. We'll define the specific columns inside these families. And for each column family, you have to enable replication. So there we go. So that's the HBase side all set up.
You said for each column family, and you set up
So the idea is in a table you have one key, and then you have a bunch of column families, and then in each column family you can have specific columns. So the idea is you might have a users table for your website. You'll have the user ID as the key, and then one column family might be login info. And that's all you retrieve when you're authenticating. You don't want to retrieve everything else in the table. So you just say, get me this key, this column family. So similarly, you might not want to index everything in your table, just a specific column family. So for each one, we're going to create a column family called tweet, and that contains the information about this specific tweet. And then all the fields that define the username and how many followers that user has, that's going to be in a separate column family. We're going to replication scope equals 1. That's just saying, okay, this column family, this does get replicated. You can have them not get replicated, and it just saves you some bandwidth. Okay. Sorry, getting ahead of myself here. So the HBase indexer is just a separate service that we need to start. I need to exit the shell first. There we go. So HBase is now running. It's doing replication. We're going to spin up the service so that now when we create data, it'll replicate it to this service. And now that the service is running, we can add an indexer. So this just tells the indexing service about this table so that when it starts getting the replicated data, it knows what we're talking about, and it knows how to load it into Solr. So let's dive into that for a second. We're looking at the third line from the top. The HBase indexer command is going to add an indexer. The -n is just the name of the indexer, so we're using the collection name _indexer. -c is a configuration, so hbaseindexer.xml. We're going to dive into that in a second and just show you how we specified the schema. It's very similar to what we saw before. Then some other properties. We're just specifying what Solr URL to post this data to, that's ZooKeeper. What ZooKeeper cluster to use, and what collection this data is going to get replicated into. So let's have a quick look at hbaseindexer.xml. Very simple. Again, we have this indexer called tweets, and then we have a few fields. We're not going to, for simplicity here, we're not going to do every field that a tweet consists of. We have the ID, the text, the data was created, the username, and the screen name. And this, by happenstance, is the same data that we're showing in Hue for Flume. Just only those fields. Go ahead.
That was kind of standard column family name column.
Yeah, so this is similar to in the schema we define fields. Very similar fields here. There are some subtle differences here. So the name is going to be the same name as in the Solr schema that we're pushing this to. And the Solr schema will still define what gets indexed and what gets stored. This is only the information HBase indexer needs to know about. The value, so this is, what we put here is the column family in HBase and the column. So what that means is you don't have to have the same IDs everywhere. A column might have one name in HBase and a different one in Solr. So the name is the field that you have in Solr. The value is the name that's known by an HBase. Column family, column ID. And then the type here, this isn't a one-to-one mapping with Solr's types. So Solr has types like lowercase and date. And right here we need to put dates that are defined by HBase's type system, which is a little more limiting. But since Solr's pretty permissive, so whatever you throw at it, it'll accept as long as it's close. So if most of the stuff I just use string, if you send it dates in the right format as a string, it'll know how to interpret them.
Can you add the location?
What's that?
Can you add the location back to the
Yeah, that could be one of your fields. And that's probably what they did, well, not latitude and longitude necessarily, but we saw in the Apache logs demo, it was extracting location information from that record. Maybe it was just a country code, or maybe it was looked up by IP address. But when you have location information, you can show it on a map, even. So really anything you want to store, you can store. Okay, so that's the configuration. We already added that to the HBase indexer. I think now we get to start creating some tweets. So let me show you the HBase app quickly. It's under data browsers, HBase, and we see our table here. So this app requires a slightly bigger window than you get on a little 640 by 480 screen here. So this might be tough, but if we close that. Yeah, so I may have to pull this off the screen for just a second just to get the window up. So there's a new row button there that wasn't on the screen. And now let me move this back. Okay, so just the bottom right-hand corner is the new row button that I clicked. So the row, we're just going to call it row 1 for now. And we're going to add the 5 fields. So the first one, as always, the family first, column name. So for the tweet family, there's the ID. And we'll just call it 1, 2, 3, 4, 5, 6, 7, 8, 9, because I'm so creative. Tweet text, and we'll say, hey, big day, you rock. Tweet created at, I think. And we'll come back to that one in a second. I have one more field here. So in the user column family, we had user name, and we had users. Screen name. Use my own Twitter handle here. And I'm going to have to look up the date format here. There we go. Okay. So just adding all the fields we want there. These are all defined in the indexer configuration. And we'll submit. And now we'll go over to Hue. And, or not yet. By the way, while I'm opening up new tabs, so in addition to Hue's interface, Solr has its own web interface. It's more for administrators. So you can just see how much data has been indexed, how many replicas and stuff like that. I think it's pretty much all read-only, but just to get some quick information about the state of your cluster, that's available there as well. Okay, so let's go into our search app one more time. Have a look at our indexes. And we'll create a dashboard. And we won't do all the style this time. I just want to show you that the data we put into HBase is now indexable. Here we go. Oh no, wrong collection. I don't think you can change the collection once you've started. Edit. I'm going to go up here. We want HBase tweets, single pane, HTML element, put it there, and there we go. You see, this is the tweet that I made earlier. So now we'll just go into HBase. We're going to change that tweet, which you can't actually do with Twitter. So here's new functionality. Change that to a different complement, entering to the crowd shamelessly. Head over here, and we'll just we'll save our dashboard quickly. Reload the page. And there we go. Now it says you are awesome. And that took me some time to reload, but I've sat here and I've tried to reload the page really quickly as soon as I've, not even reload the page, just change my search query as soon as I update something in another tab. It's not instantaneous, but I've not yet been able to catch it not keeping up. I'm sure you get different characteristics of scale, but this is pretty snappy. So as soon as a user changes something on the website, you can have your data scientists already seeing that update in the search data. So that's the 3 different types of indexing we talked about. Indexing in batch, indexing stuff as it comes in your cluster in Flume, and indexing data even as it changes inside HBase. Let me run through, we're a little short on time, I think. Let me just show you a Sentry configuration file, just so you can see how that's done. So this file, as I said, it's going to use an outside mechanism to map your user to a group. If you're part of the admin's group, you get the admin role. Part of the user's group, you get the user role. And again, you can be in as many groups as you want, so you can inherit as many roles as you want as well. Down below, for each role, we define the permissions. You can do it on a document level or collection level. Just to be simple, I've done collection level. So this admin role, they can do all actions on all collections. So on MapReduce tweets, action equals all. Flume tweets, action equals all. There's actually a bug right now that's supposed to get fixed really soon that I found while doing this demo. All is what's documented. You actually have to do an asterisk right now. In theory, you should be able to do both an asterisk or all, but all, for some reason, is not complying with query permissions. And at the end of this line, you can't see it, but I say collection equals HBase, action equals all. And so that means the admin role can do anything. The user role, once they're logged in, they can only query the MapReduce tweets table and the HBase tweets. They don't have access to the Flume stuff. So yeah, just a quick example of how you define the permissions there. I'm not going to do it right now because, as I said, it'll be error prone, and I'm already at the time I wanted to spend on this. But basically, if you want to do it in the VM, what you need to do is you need to enable Cloudera Manager. Right now, everything's running just using raw CDH, kind of the Apache Big Top style deployment. There's a shortcut on the desktop just to launch Cloudera Manager. Let me show that to you. You need to make sure the VM has at least 8 gigs of RAM. By default, it's going to use 4. Most people who are using the VM seem to only have that much. But if you have enough RAM to run all the services, add 8 gigs of RAM, double-click the Launch Cloudera Manager thing. It's going to shut down all the services that are currently deployed using kind of the Linux way. And then it's going to relaunch everything using Cloudera Manager. If you go to the web browser, there's a bookmark there for you to Cloudera Manager. Right here. Just log in. Again, the username and password is Cloudera. You'll see the list of all the services. You'll see the monitoring. You'll see some graphs about the disk I/O, the network performance, things like that. What you services? There's a script in this demo called Kerberos. Just run that. That's going to set up Kerberos on your system. And then in Cloudera Manager, just click. There's a button to enable Kerberos. The README details all the information you need to provide. It's going to set up the authentication and everything. Beyond that point, you shouldn't have to do anything. You just have to log into Hue as the user you want to test, and you should see all the Sentry access controls coming into play. You'll be able to configure Sentry in Cloudera Manager. Again, don't have time to go over all of it, but it's detailed pretty well in the README. And if you run into issues, you can reach me on Twitter. Just as the closer here, let me bring up my contact info. Feel free to contact me with questions on Twitter. And if I don't know the answer, I will try and find the people who do. Let's put that over here. Okay, so there's my Twitter handle. And let's just share that on the Google Hangout as well. Okay, so that's everything I had prepared. If there's any questions you want to bring up now, we'll do that. But also feel free to come up and talk to me afterwards, and we can talk about anything specific you want to talk about. Any questions? Yes?
What is Spark really? Like you didn't talk anything related to Spark. Right?
Yeah. So I mentioned this idea of like the data hub, and the idea is to be able to analyze all the data different ways in place. So tonight we just talked about kind of the search use case. The benefit to this is, yeah, you can use Spark. Spark's included in the VM. You just type PySpark, and you can use the Python interface or whatever you want. The web interfaces are in there as well. And Hue has an app for Spark that's already configured and ready to go. The idea is, yeah, you can use Spark, and you can use it on the same cluster as all your search data. Just wasn't the topic of tonight's meetup. But yeah, you can use Spark. You can do Impala for relational queries. You can still use MapReduce for batch stuff. And more use cases coming.
Just to add to that, and not to plug our group too much, but we just had a presentation on Spark, I think, 2 weeks ago, was it? Yeah, and that is up and recorded on the site as well. So if you want to look into it more, you can find out more about it there.
Okay. All right, well, I say you asked some awesome questions, so I think you should get first pick of the swag. Would you like a book? Would you like a T-shirt? T-shirt? All right. Well, come on up and grab this. We have a bunch of sizes.
Yes,
So-
thank you, Sean.
Yes.
Thanks. Yes, I will stop broadcasting and we'll give away the remaining swag via quiz.